Hey everyone, and welcome to a new video. It's Federico here. This video is the first of a series in which we are going to build a 3D game in Max in JavaScript using the new V8 object, the Max9 V8 object, which allows us to use the latest JS syntax. And we are going to build a game which resembles a sort of tower defense style of game. Maybe we will incorporate some audio stuff into it to take advantage of the Max audio capabilities. Most probably, I don't know yet exactly how this is going to turn like. What I know is that I want to have a menu here where we can choose the shapes that we want to drop, that we want to place in this grid. And then there will be some sort of enemies, there will be some sort of projectiles fired or something like that. So some sort of tower defense game. But the whole idea of the project is very much still open, so could be everything. What I really want to show you here is how to create a semi-complex project using JavaScript and Jitter in Max. I think JavaScript is really the best way to work with complex projects, especially with Jitter in Max. So I want to show you a couple of tricks, stuff that maybe you don't know, and hopefully create something cool along the journey. So without any further ado, we will start by creating the simple scene with a grid and some 3D models. As you can see, it's all contained inside the V8 object here, apart from the Jit world. Sorry about the noise, my baby is banging in the background. As assets for this 3D game, I'm using this package from Kenny's website. Kenny has a lot of free 3D assets, so you can download them. You can download this specific package from his website. I will put a link in the description. You can also choose to support him, which would be awesome. So I think this is it as an introduction, and without any further ado, let's jump into the action. Okay, so let's start. I've got here a Jit world, which I've called grid game world, and I gave it a couple of attributes. I gave it floating 1, so the window doesn't go behind the patcher. Enable 1, so it's enabled by default and full scale anti-aliasing, so the edges of the 3D shapes are smoothed out. And I've also opened the folder in which this patcher is in Visual Studio Code. So if you go Visual Studio Code, open folder, and I open that folder. And I put also inside this folder another folder called 3D Models, in which I've put the folder which I downloaded from Kenny. So let me show you how this folder actually looks like. It looks like that. The JS project pattern is on my desktop. Inside there is the Max path and these 3D models with the Kenny folder inside with the models. I deleted the other formats. I just kept the obj because it's the only one that we will need. And inside are all the obj objects. So that's how the folder looks like. And this is what we got here inside Visual Studio Code. So now let's start and let's create a V8 object so we can use the latest JS syntax, and I will call it gridgame.js. Now if I double click on the V8 object, it will open the default Max editor in which I will write in this file the line autowatch equal 1. I will save that in the same folder, so the JS project pattern. I will just save it here. And now if I close the editor, in Visual Studio Code, you can see that there is also this JS object with the autowatch attribute set to 1. And this attribute for the JavaScript file means that every time I update this file here, it will also update it in Max, the V8 object in Max. So I want to start by creating our grid, so our 3D grid in which we will place our objects. In order to do that, I like to work like sort of object-oriented programming. I'm not really a pro, but that's just what comes easier to me. So what I want to do here is create a new file. I can just create a new file with this icon in Visual Studio Code, and I will call it gridgame_grid to mean that this is the grid class with a capital G. And inside this file, I will create the grid class. And in the newest JS syntax, we have this class constructor, which is more familiar for people used to work with object-oriented programming languages like C++. And before we had to create these classes with the function constructor. Now we can just use the class constructor. And inside there is a constructor function for this class in which we can actually pass values from when we create a new instance of this class. I don't think we need to pass anything for the moment. We will just create our grid shape. to draw the grid in the world, and I call it this GL shape. GL to remind myself that this is a GL object, and this is a jitter object, so new jitter object GGL grid shape. Right, and we don't need to put any draw to attribute, I think, because it will automatically find the JIT world and draw to it. What we want to say is that this is going to be a plane. We want to say that it should be drawn as a framework. So with poly mode set to 1, 1. So it will just draw lines instead of a solid shape. And then set the color to white. So the color is an array. If we declare this object in JavaScript, we just set it to full white. So let's now go in the main file and include this other file. So it's like if we are placing this other file on top of this file. So let's create a constant variable, which means it cannot be changed. It will always be this object. And I call it g_grid. And g_, I use it to say that this is a global variable. So we can use it anywhere in our code. We can use it also inside other classes. We can use it anywhere. And this is a new grid. So if I say that now, we should see, maybe I need to also delete and recreate this object, right? We can see the grid shape appearing in our rendering window. Cool. I want to modify it a bit because I don't like that this is rendered as triangles. I would like to have squares. So we can do that with the GGL shape. There is a grid mode attribute, which is set to 1 by default. And if we set it to 0, this will show squares instead of triangles. Very nice. Now, one thing that we should do is to free the resources for this jitter object that we allocated when we created it, because JavaScript doesn't do it automatically. If it will be a max object, when we delete the object, the resources allocated for the objects are destroyed. But if we create this object in JavaScript, we need to manually free these resources. So in each class that has resources to free, I will create a destroy function. And inside this function, I want to free the resources for all the GL and the jitter objects that we have in the class. And the function to do that is free peer. So the GL object has this free peer function that will free the memory allocated for this object. And this we need to do because we are basically creating a C object when we do that. And we have its representation here in JavaScript, but this C object never gets deleted unless we call the free peer function. Cool. So where do we call this function? We can define in the main file a function called notify deleted. And this is a function that must be written exactly like this, notify deleted. And this gets automatically called by Max when the patcher is closed or when actually the V8 object is deleted, or the JavaScript object, they both have it. So inside this function, we call the destroy function. So every time this V8 object is deleted, this will call the grid destroy function and we free those resources. Okay, so we are at a good point. So what I will do now is actually rotate this grid because I want to have a horizontal grid. This is a 3D game in which the floor is horizontal, the grid is horizontal, and we place the objects in the horizontal grid. So what I want to do is rotate it so that it is horizontal, and I can do that using the rotate XYZ attribute. In JavaScript, we have to assign it an array, and I will rotate it on the x-axis by 90 degrees. So if we check it now, you can see that the plane is perfectly perpendicular to the camera, so we just see it as a line. And if we will create here a GGL camera, and maybe set tripod 1, and then create a JIT anim drive with UI listen set to 1, can connect it to the camera, and we can see that this is still a 3D grid, and we can move around in the scene and look at it from every possible angle. Now, it would be really nice to have the GGL camera and the anim drive also inside JavaScript, because as we said, we want to have most of the objects we are creating inside JavaScript. So we will do exactly that. So let's create a new file here and let's call it grid game underscore camera. This will be the camera class. So let's create a new class, call it camera. And the constructor, in the constructor, we can then define the actual camera. So this GL camera is equal new jitter object ggl camera. And let's give this camera a bunch of attributes. We want to give it the tripod attribute so it doesn't tilt. And then we want that this camera probably, we want it to look at the center of the world. So it doesn't go roaming around. We cannot really change what the camera is looking at with the mouse, and this makes it a bit more easy to control. And then we want to set the lock look equal to 1. So this will always look at the center of the world. Nice. I think this is it for the camera. Let's create, let's now create the anim drive. So git anim drive. And this is a new jitter object, git anim.drive. And this git anim drive will have the UI listen attribute set to 1 or true. It's the same. True gets converted to 1 in JavaScript. And let's give to the git anim drive the target name, which will be our camera name. So this GL camera.name. And again, we need to free the resources for this GL and jitter objects when the patcher is closed or the V8 object is deleted. So let's create a destroy function here and say this GL camera.free peer, and then this git anim drive.free peer. So inside our main file, we can say, we can actually first include the camera code. Then we want to create another constant variable, and it's going to be our g camera. It's a constant global variable. New camera. We're not passing any arguments to the constructor because we don't really need to set anything for different cameras and different grids, because I think we will only have one camera and one grid, so that's okay. And then let's say the gcamera.destroy in the notify deleted function. So let's now delete and recreate this object. And I'm trying to move the camera with my keyboard, with the keys, but it's not working. And I'm asking myself if this is due because we need to set the draw to attribute for the GL camera, and especially for the anim drive, because it will not find it automatically, I think. So let's do that, and let's go, let's actually go in our main file and create another constant variable, and also global as well, of course. And this will be the name of our world, which is grid game world. And I'm creating it here as a variable because if we choose then to change this name, we only need to change it once from this variable. And it will be applied on all the code base. So let's go here and set the draw to attribute of the camera to gDrawTo, and as well for the git anim drive draw2 equal gDrawTo. We could pass this as an argument to the constructor, and probably this will be better practice. I think instead of just using it as a global variable that is then used inside the single files, this will make it a bit more clear that this is being used by these objects. So that will probably be better practice. I just think it doesn't really make so much difference for our case, so I will just keep using it like that. So let's delete and recreate the file, and great, as you can see now the camera is moving. So what's happening here is that with git anim drive you can move the camera or the object attached with the Q, W, A, S, D, Z keys. And that's what I'm using here to move the camera. Now it is moving a bit too fast, so what I want to do is to reduce the speed for the git anim drive. So we can change here its speed attribute to something like 10. And if I delete and recreate the V8 object, you can see that now the movement is a bit slower. And I also would like to get rid of the ease, which is when I start moving the camera and stop it, it will not just start moving right away and stop right away, but will like slide slowly to motion or stop. So we can change that by changing the ease attribute or gtime drive, and maybe we can set to something really small like 0.1. Let's see. Yeah, now we have a much more snappy movement. Great. So to have just a bit more satisfaction here with these graphics, let's create a 3D model and place it in the scene. So what I'm going to do is to create a new file here for a new class, which we're going to call model.js. And so class model constructor. In the constructor here, we're going to pass the path to the model. So we will be able to load a different model for each instance of the model class. And what we need to have here is a GL model variable. And this will be a new jitter object GL model. And this GL model should read the model path. And since this is a message in Max, the read message, it's not an attribute, right? So we can call it in JavaScript as a function, not just assigning it to a variable, but this is actually a function in JavaScript. You can see this is a message here in Max. So let's actually write it down. A message in Max is a function in JS, and an attribute in Max is simply a property of the object in JS, right? So, okay, so this model will be placed at the center of the world. I think this is good enough for the moment. Let's create again the destroy function. So we will say this GL model dot destroy, dot free peer. Destroy is just the name that I give it, but the actual Max function is called free peer. So in the main file, let's include this file as well, the model. And let's create our first model here. So we're going to delete it. It's not how we are going to do it's not how we're going to do it, so we're not call it G model, but just model. And it needs a path, because if I don't give it a path and I just save it, it will, and I just save the file, it will open this prompt to select a model from the hard drive and load it. So I will just select one, but we actually need to destroy and recreate the V8 objects for it to work, so it will ask me again. And there we go. There we go. The model has got loaded. I just selected it manually. And as you can see, it's pretty big. This is something that we're going to deal with it later. So let's now load it not with the prompt, but just with a path that we hard code here. So we can do something like patcher to get the relative path from this patcher. And then we can say 3D models. So we are now inside our 3D models folder, models. And let's see, let's just take one of them. And as you can see, the OBJ format is just a bunch of vertices and normals and maybe color. So let's select just one. I will just select one randomly, detail dirt.obj, right? And if I recreate the object here, okay, I got an error that it cannot find that because I forgot to say that this is inside the folder called obj format. So after models, we should say obj format. Oops. So that's how the file name looks like. Oh, and again, I forgot part of the path, which is before models, there is Kenny underscore tower defense. No, actually, it is a dash defense kit slash. Let's see if this now works. Oh, okay, now this works. This was the correct path. So this is pretty inconvenient to write every time, right? So what we can do is to go inside our model class. Just copy everything for a moment. Let's go in the model class and let's create here a constant variable, which is our path prefix. And let's just pass the whole path minus the name of the object itself. So every time you change the position of these objects, you should modify this path, but if you don't touch the position of the objects inside your folder, then this path, we can always use this path. And so this will not be the model path now, but the model name. And then we can say path prefix plus model name, and then we can also add obj to that. So in our main file, we don't need to write the full path, but we can just say detail dirt. We don't even need to say the actual model, the actual file type. We can just say the name of the object, and there we go. We got it. We got it rendered. Let's go in our model class again and say that GL model should normalize these objects, so they will always be the same size by default, and then we can rescale them. So our grid by default is 19 squares by 19, I think, right? Because the grid is 20 by 20. So let's actually first make the grid 10 by 10. So if we go in our grid class here, we can say this ggl shape.dimension. If we want to have it 10 by 10, we can make the dimension of this grid 11 by 11. So there will be 11 by 11 vertices, which gives us 10 by 10 squares. So this looks like this. And then we can scale the 3D objects to fit in one of those squares. So let's go in the model class and say this GL model.scale. Scale it by a single value of 0.1. And I think that's correct. It will be in the center of the world, so we cannot really fit it inside one of those squares, but it should be correct. Actually, we should make the dimension of the grid as a property of the grid object. So this dimension equal 11 by 11. So we can use this here. And then inside our model class, and assuming that our grid is always a square, we could say that the scale is equal to ggrid.dim0, so just one of the dimensions, since it's a square, are the same, minus 1, and then basically 1 divided by that. So 1 divided by, in this case, 10 will give us 0.1, which then it will be the correct scale. So it's always going to be the correct scale for whatever dimension of the grid. So if we make it 15 by 15, this will get smaller, and so on. So the only caveat with this approach is that the grid class must exist before we declare any model, because otherwise it will not find it and will give us an error. Let's give it a random position. So we will just place it somewhere randomly in this grid. And let's maybe create a function for that. So set random position. So this GL model dot position, and let's create a variable for the position. And this is going to be an array with three numbers inside, and this is going to be math random multiplied by 2 by minus 1, so it will be in the range minus 1 to 1, because our grid is, the scale of our grid is 1, so it will go between minus 1 and 1 on the X and Z axis. So we should simply be able to place it on the X axis at a random number between -1 and 1. On the Y axis, we just want to set it to 0. And on the Z axis, also between -1 and 1. And then let's assign run the pos to that. So when we go in our main file, the model set random position, it will be placed at a random position inside our grid. Okay, and just for fun, let's create another one. This is all stuff that we're going to delete later, because this is not how we're going to do it. Let's maybe choose a different model. So enemy UFO C sounds good. So we just need to input here the name of the model, enemy UFO C. Delete and recreate, and there we go. That is our UFO. Cool. Okay, so I will stop here with this video because I have limited recording time before my baby comes back home. But I will try to keep those coming out fairly steadily. So thank you very much for following. I hope it is interesting, and I hope you stick around with the series, because we're going to create hopefully something cool with the new V8 syntax, and maybe I can show you some cool JS Max tricks. Okay, so thanks a lot. As always, the patcher will be on my Patreon, and the video as well will be on my Patreon, so you can watch it there without any ads for subscribers. And if you join my Patreon, you will also support the channel, the creation of these videos, and you also have access to hundreds of patches that I shared there during the years. So it would be really awesome if you will check it out. Anyway, thank you very much for following, and I will see you in the next episode. Take care, have fun, and see you soon. Ciao.